we are going to take a look at some more factoring practice. So we talked in Unit 8 about factoring things with 3 terms and factoring things with 2 terms. We talked about looking for greatest common factors or GCFs. So we're going to see all of that in our practice today. So to start, we're going to look at number 1. Remember, the first thing I always want to look for when I'm factoring is there a greatest common factor? Is there something I could divide out of all of these terms and not have a remainder? For number 1, there's no common factor. -7 and -18 don't have any common factors. Our x squared term doesn't have a lead coefficient that I can see. Our lead coefficient there is just 1, so nothing I'm going to pull out as a GCF. That means that we're going to go straight to looking for factors of -18 that add to -7. Remember, to multiply and get a negative number, I had to have 1 positive and 1 negative number. So I know 1 factor is going to be positive and 1 factor is going to be negative. Since we're trying to add up to a negative number, that tells me that my negative factor is going to be the bigger of the 2. So my bigger number should be negative. So as I'm looking at factors here, make a list if you want. 1 times -18, that would add to -17. 2 times -9, that would add to -7. Those are the ones that I want. So I can go ahead and write this in factored form. X plus 2 times x minus 9. Since I don't have an a value bigger than 1, I don't see anything in front of my x squared term, I can go straight to my factored form. Number 2 is the same type of problem. We're going to start by looking for a greatest common factor. I don't have anything I could divide out of all of these terms and leave no remainder, so we're going to look for factors of -14 that add to -5. Same idea here. To get a negative number, we need a positive times a negative. And since we're adding and getting something that's still negative, our negative factor is going to be larger. So we want 2 times -7 here. That would give me x plus 2 times x minus 7. And then number 3, same idea. No GCF to pull out here, so I'm looking for factors of 8 that would add to -9. This time I'm factoring a positive number. So to get a positive number, I need a negative times a negative or a positive times a positive. Since we're going to add up to -9, that tells me I want negative times a negative. So this would be -1 times -8. That would add up to -9. My factored form is x minus 1 times x minus 8. Number 4 is a little different. We don't have 3 terms here. I still want to start the same way by looking for a greatest common factor. If I look at my terms here, 7x squared plus 9x, these both have an x. So that's my GCF here. I'm going to pull out x, factor out x from each term. That would leave me with 7x plus 9. I've taken an x out of each term. And now I don't have x squared anymore, so I'm done factoring. All I could do there was take out a GCF. Number 5, again, every term has an x, so I'm going to pull x out as a GCF. That leaves me with 3x squared minus 5x plus 2. Okay. I didn't have a number I could divide all of these by evenly, so only the x is my GCF here. And now since I do see something in front of x squared, I have a lead coefficient or an a value that's not 1, I want to use AC method. So I'm going to take my a value times my c value, so 3 times 2, that gives me 6. And I'm going to look for factors of 6 that add to -5, still trying to add to that middle number. The factors I'm going to want here would be -3 times -2, that would add to -5. And now since we're using AC method, we can't hop straight to our factors like we did in the top row. We've got to rewrite our quadratic piece. So we keep that first term the same, and then we use the factors that we've chosen to split up the middle term. So this will be -3x minus 2x plus 2. First term's the same, last term's the same. Middle terms, if I combine them, I would get back to our original problem. So -3x and -2x would be -5x, but we split it up. Now I'm gonna split this up into my groups and look for the GCF for each group. The GCF for my first group, I can divide both of these by 3, and they both have an x, so 3x would be my GCF there. When I divide 3x out of this first term, I'm left with just x. And then here, 3x divided by 3x, That would just be 1, so x minus 1 there. For my second group, I can divide both of these numbers by 2. Since my group starts with a negative, I'm going to take out negative 2. That would leave me with x, and then 2 divided by negative 2 is minus 1. Remember, anytime I'm using AC method, I want to make sure that my numbers in parentheses are the same, or my expressions, I should say, in parentheses are the same. They are, so I get to pull that out the same as I have my GCF so far this problem. And then my other factor is the stuff that's left over when I pull it out. So 3x minus 2 is my other factor. 3x minus 2. And then don't forget your GCF from the beginning, plopped down in front here. There's my factored form. Number 6, same idea. I want to start by looking for a GCF. There's not a number I could divide 10, 89, and negative 9 by without a remainder. So again, we're going to use AC method here. So 10 times negative 9, that gives me negative 90. And I want factors of negative 90 that would add to 89. Okay. Since I want a negative number, it's going to be a positive times a negative. And I want my number to come out positive. So the positive number needs to be the bigger number. Okay. So this would be negative 1 times 90 would give me negative 90. If I added them instead, I'd get 89. So those are the factors that I want here. So I have 10x squared minus 1x plus 90x minus 9. Remember, first term and last term stay the same. And now we're going to split this up into our groups. The GCF for my first group, the only thing these have in common is x. So I'm going to pull out x. That leaves me with 10x minus 1. For my second group, I could divide both of these by 9. I'm going to pull out a 9. 90x divided by 9 leaves me with 10x. 9 divided by 9 would be 1, so minus 1 here. Again, my stuff in parentheses is the same. That's what I want. So I pull it out. 10x minus 1 comes out. And I'm left with x plus 9 for my other factor. There's my factored form. And number 7 is one of those two-term problems that we've seen where I don't have a GCF to pull out. Right? 16 and 9 don't have any common factors. In number 4, both terms had an x, so we could pull out a GCF of x there, but I don't have that for number 7. So this is a difference of squares problem. Okay, if you can't pull out a GCF and you've got two terms with an x squared and you're subtracting, I want you to think difference of squares. So remember, the idea was I look at what did I square to get the first thing and what did I square to get the second thing. So to get 16, we would have to square 4. To get x squared, we'd have to square x. And to get 9, we'd have to square 3. My factored form then is 4x plus 3 times 4x minus 3. That first thing that I squared goes at the front of each factor. The second thing I squared goes at the back of each factor. 1's plus, 1's minus. Okay, so the first thing always at the front for each of my factors. The second thing always at the back for each of my factors. Opposite signs in between. That's difference of squares. For number 8, we're back to something with 3 terms. Again, I want to start by checking for a GCF. 9, 15, and 4 don't have a common factor other than 1. We're going to go ahead and go to AC method. So A times C, 9 times 4, that gives me 36. And I want factors of 36 that can add to 15. Okay, make a list if you need to. So 1 times 36, 2 times 18, 3 times 12. Oh, that's it. That's what I want. That will add to 15. So remember, we keep our first term and our last term the same. It's only the middle that we change, plus 3x and plus 12x and plus 4 at the end. Now we're going to split this up into our groups. The GCF for my first group, I can divide both of these numbers by 3, and both terms have an x, so 3x is my GCF there. 9 divided by 3 is 3, and again, we're taking out an x. Here, 3x divided by 3x, that's just 1. For our second group, 12x and 4 have a common factor of 4. I can divide those both evenly by 4. So this would leave me with 3x plus 1. My stuff in parentheses is the same, so I pull that out. front, 3x plus 1. And then my other factor is what's left over, so 3x plus 4. Number 9, again, I want to start by looking for a GCF. I could divide all of these numbers by 2. So I'm going to factor out 2. That would leave me with x squared plus x, or 1x if you'd rather, minus 12. And now I can keep factoring what's in parentheses here because I still have an x squared term. So we're going to look for factors of negative 12 that add to 1. That would be 4 times negative 3. Now I don't need to use AC method here because my lead coefficient, my A value, is just 1. Okay, so this inside parentheses is a problem like 1, 2, or 3. So this would become x plus 4 times x minus 3. And then again, don't forget your GCF in front. Number 10, we don't have a non-1 A value. We don't see anything in front of x squared. So we're just going to look for factors of 35 that add to negative 12. Let's see, we're going to need 2 negative numbers because to get a positive number, I had to do positive times positive or negative times negative. I want 2 negative numbers that would add to negative 12. I think I want negative 7 and negative 5. Again, if you need to make a list, make a list. My factored form here then would be x minus 7 times x minus 5. Number 11, I've got just 2 terms this time. I want to start, as always, by looking for greatest common factor. Is there a GCF I could pull out? In this case, 81x squared and 49, no common factors there. So since I have something with x squared, only 2 terms and subtraction, I want to think difference of squares. I had to square 9 to get 81, and we have to square x to get x squared. We would square 7 to get 49. So my difference of squares pattern tells me that my factored form would be 9x plus 7 and 9x minus 7. And there's my factored form. Number 12, I don't see anything in front of x squared, so I don't need to use AC method here. I'm just going to look for factors of negative 20 that would add to 1. If you need to make a list, make a list. Since we want a negative number, we know we have to have a positive times a negative. Since I want it to end up, when I add them, as a positive number, I know that the positive factor needs to be bigger. Okay, so I could do 1 times 20. The positive factor is the bigger one, so our 1 would be negative. That adds to 19. That's not it. I could do 2 times 10. This would add to 8. 20 is not divisible by 3. It is divisible by 4. 4 times 5. And negative 4 plus 5 would give us positive 1. So those are the factors that I want. So this would be x minus 4 times x plus 5. We're on to our last few problems here. Number 13, no GCF here, no common factor for all of my terms. Remember, GCF means greatest common factor for every term, not just for some of them. So nothing for all of my terms here, so we'll use AC method. 2 times negative 9 is negative 18. And I want factors of negative 18 that add to negative 3. Again, I need a positive times a negative. Since I want to end up with a negative, that means my negative factor should be bigger. So I could do 1 times negative 18. That doesn't add to negative 3. 2 times negative 9 also doesn't add to negative 3. 3 times negative 6. That would add to negative 3. So those are the factors that I want. Now remember, this is AC method, so we keep the first term the same and rewrite the middle, plus 3x minus 6x, using the factors that we picked. And then the last term also stays the same. Now we take our 4 terms and split it up into groups of 2. The GCF for my first group, both these terms have an x. I don't have anything I could divide 2 and 3 by, so just x here. That would leave me with 2x plus 3. For my second group, 6 and 9, I could divide those by 3. Since my start term for my group, the front of my group, is negative, I'm going to pull out a negative 3. So that means negative 6x divided by negative 3 would be positive 2x. Negative 9 divided by negative 3 would be positive 3. My stuff in parentheses is the same, so I can pull that out front, 2x plus 3. And then my other factors, what's left over? X minus 3. There's my factored form. Number 14. Again, as always, start by looking for GCF. No greatest common factor among all these terms, so I'm going to use AC method. 3 times -8 is -24, and I want factors of -24 that add to 10. This is going to be 2 times 12, and since I want positive 10, my factor of 2 will be negative. So 3x squared minus 2x plus 12x minus 8. Split this up into groups of 2. The GCF for my first group is x. That leaves me with 3x minus 2. For my second group, the GCF here would be 4. Divide both these numbers by 4. 12x divide out 4 leaves me with 3x. -8 divided by 4 is -2. My stuff in parentheses is the same, so I have 3x minus 2 and then x plus 4. There's my factored form. Finally, for number 15, again, I want to start, like always, by looking for a common factor among all my terms. I have one here. I can divide all of these terms by 3, so I'm going to do that to start. That would leave me with x squared minus 5x plus 6. And now, what's in parentheses is still factorable since I still have x squared. So I want factors of 6 that add to -5. Right? If they don't have anything in front of x squared, I don't need to use AC method. Just factors of 6 that add to -5. That would be -2 times -3. So the factored form for this part would be x minus 2 times x minus 3. And then don't forget your GCF of 3 in front there. And there's our factored form for our final problem. So remember, always start by looking for a greatest common factor, a GCF. Take one out if you can. Then look to see if you need to use AC method, if you have a difference of squares, or if it's a trinomial more like number 10, where I just need factors of C that add to B.